All right, in this video, we're going to talk about molar conversions. And as you can see, this is just one depiction of how we can convert from moles into, for example, particles, moles into volume, we can do moles into mass, or we should be able to jump and go from one to another. We should be able to go from mass to particles, but obviously we have to go through the moles. If we wanted to go mass and figure out the volume or volume in the mass, we have to go through the moles. So the mole is a really important part here, and I apologize for part of these slides showing up on my face, but we'll deal with it. I just want to have this up here as we do a couple of examples just to show you how you can convert using the mole. Now we have to remember, obviously the mole is a concept kind of like 1 foot is equal to 12 inches. The mole, we should remember, is 6.02 times 10 to the 23rd particles. And that could be either atoms, it could be molecules, or it could be considered something as formula units, which is what we talk about when we're talking about, for example, ionic compounds. Now, one of the most common ones is going to be between mass and mole, especially if you're taking the New York State Regents exams or New York State chemistry. To go between mass and mole, mole and mass, that's the one that appears the most. But once in a while, volume will appear in there, particles will appear as well. So I'm going to do a couple examples, just kind of walking you through how we would convert from one to another. So let's say, for example, I have 4 grams of salt, and I want to know how many moles that is. Obviously, we need to know what the GFM is. The GFM stands for gram formula mass. And we also know that as the molar mass. You might hear formula mass, molar mass, and gram formula mass interchanged. Formula mass would be just for one individual unit or one atom, one molecule, where gram formula mass is talking about a whole mole of that material. So if we did that, if we're going to use sodium chloride, obviously you're going to need to use your New York State reference tables for chemistry. And when we look up those numbers would be on the periodic table. They would be on the top right of every box. So when you're looking at that periodic table and you're looking at the information, the top right of each box has the mass or the atomic mass. So sodium, for example, has a mass, according to this, of 22.9877. So we're going to round that up and we're going to call it 23. Chlorine has a mass of 35.45. We're going to call it 35.5. Now we're going to use grams for the sake of this because we're dealing with the mole, and so I'm going to put that to the side, and I want to be able to convert. So if I know sodium chloride is made up of 1 sodium and 1 chlorine, then collectively, when we add those two together, we know that that adds up to 58.5 grams. Okay, that is the mass per mole. So if I know I have 4 grams, all I have to do is divide by the gram formula mass in order to get to the mole. So there's 2 ways to set this up. There's the way that I like to show as far as the factor label method in dimensional analysis. We are going to multiply by 1 mole of salt is 58.5 grams of salt. Now I can cancel out or factor out my labels. So in all intents and purposes, I'm really just dividing by the gram formula mass because we have a multiplication by 1, which really isn't going to do anything. So really it's 4 divided by 58 grams, which is going to give us some number. Okay, so if we calculate that, clear this out first, 4 divided by 58.5, that equals 0.06 moles. Okay, and just make sure, check my calculation again, 4 divided by 58.5 equals, so about 7%, okay, if we were to go through of a mole. So again, all we're doing is dividing by the gram formula mass. If we want to go in the opposite direction, instead of dividing, we're going to go and we're going to multiply, okay, because obviously the opposite of dividing something is multiplying it. So let's say, for example, you have 5 moles of salt, and you want to know what the mass of that would be. All I would do is then multiply it. I know that 58.5 grams of salt is 1 mole of salt. So that mole of salt cancels out. Now it's just a multiplication. So 5 times 58.5 equals 292.5 grams. pick up my little thing here, put that to the side. So that's going from mass to moles, moles to mass. And the concept would be the same if we went from moles to volume, volume to moles, moles to particles, particles back into moles as well. So let's say, for example, you're doing an experiment and you know that a gas is going to be released, and you capture, maybe you measured the volume of the balloon, or maybe you measured the volume of the gas, and you know that, for example, 48 liters of gas was created. And the question is, well, how many moles is that? Well, I know that 1 mole of gas is 22.4 liters of gas. So my liters of gas will cancel out, and now I just have to divide by my volume, okay? So again, to go from volume into moles, going from volume into moles, we're dividing. Hopefully you can see that symbol there. There's a division there, there's a multiplication there. So if we take 48 divided by 22.4, we get 2.14 moles. Okay, we are going to divide by the molar volume. That is a magic number, 22.4. That's what Avogadro calculated. You've probably learned a little bit about Avogadro's law that states that equal volumes of materials will have equal particles. And again, that's when we're talking about things like the mole, assuming that standard temperature and pressure conditions are met. So if I know my volume, I can divide by 22.4 to figure out the number of moles. If I want to go the other way, let's say I know the number of moles I have and I want to know what volume that would occupy. Instead, to go from volume into, from moles into volume, we're going to multiply by 22.4. So let's say I have 10 moles of gas. I know that 22.4 liters of gas is 1 mole of gas. So the moles of gas would cancel out. 10 times 24, easy enough. We don't need a calculator here. 224 liters. Okay, so if you were going to go from mole into something, if you notice going out, we're always multiplying. From mole into mass, we multiplied. From mole into volume, we multiplied. To go from mole into particles, we're going out, we're going to multiply. Okay, in each case, we're going to be multiplying. So the same concept can be used in multiple different scenarios. So if I had 0.36 moles of gold, let's say, I want to know how many atoms of gold that is. I'm going to take 1 mole of gold, or silver, silver, and we know that 6.02 times 10 to the 23rd atoms of silver are going to be present in that mole. So my moles of silver cancel, and we can just now do our multiplication. Now, this is where it gets a little tricky because we have to remember scientific notations involved. So 0.36, I'm going to multiply that by my 6.02, and I'm going to get 2.167. Now, that is already a number between 1 and 9.9, so I can leave it, and I can keep my scientific notation the same. So 2.167 atoms of Ag, okay? And that should make sense. If a whole mole has 6 times 10 to the 23rd, then about a third of a mole should have about a third of what 6 is. And a third of what 6 is, obviously, is 2. So it should make sense as you're going through and looking at those numbers mathematically. Now, the other way around, let's say I have 4.7 times 10 to the 22nd atoms, and I want to know how many moles that is. I have to go the other way around. I know that 1 mole is 6.02 times 10 to the 23rd atoms. So now I have a difference of not only flipping the formula around, where instead on top we multiplied by 6.02, now we're going to divide by 6.02. If I think about this, I have to still do some math. I'm going to do the math. 4.7 divided by 6.02, and that gives me an answer of 0. I'm going to come up here a little bit. 0.78, but that now is times 10. When you have your exponents, remember, if you're dividing exponents, 22 and 23, they have to subtract. So 22 minus 23 is 10 to the minus 1. So what that would mean is 0.078. If it's a negative exponent, we're going to move our decimal 1 place to the left. And now I have that many. In this case, we're converting to moles. And now, again, does the answer make sense? 6 times 10 to the 23rd, I've already moved my decimal over one place, and now I have a very, very small amount, okay? If I were to go from 23, or 10 to the 23 times 10 to the 22nd, that's 10 times smaller already. Just looking at the exponents, it's a decrease of a factor of 10. So if I were to think about having 1 mole to begin with, and I move that decimal over, now I'm at 0.1 mole. Okay, if we think about it that way, 0.1 mole is a tenth, or 10 times 10 factors less, like going from 10 to the 23rd to 10 to the 22nd. And now I have to make a comparison. 6 down to 4 is also smaller. So my answer should be smaller than 0.1, and obviously it is. This rounds, if we think about this, this would round to 0.01. So obviously it's a lot smaller. So check your math, make sure that it makes sense when you go through. And again, overall, we can go from moles to mass, mass to moles, either by multiplying or dividing by the gram formula mass. We can go from moles to volume, volume to moles, either by multiplying or divided by 22.4. And we can go from mole into particle, particles back into mole, either by multiplying or dividing by Avogadro's number, 6.02 times 10 to the 23rd. Well, the question comes into mind, well, what if you happen to jump from one to another? If we do that, all we have to do is the same process, but just lump them all together, okay? So give me a moment here. Let's say I want to go from mass to particles, okay? And if we know the starting mass, let's say we start out with 5 grams of salt. Okay, common value in a science lab, we're not going to typically have you weigh out a whole mole of materials. We usually do a microscale version. And so we should be able to calculate and maybe do theoretical yield. So I'm going to give you an example of that in a minute as well. So I know if I have 5 grams of salt, that's going to be the mass. So we have mass. Obviously, we got to go to the mole. And then finally, we can go to particle. In order to get from mass into moles, we're going in, so we're going to divide by our gram formula mass. I know that 1 mole of salt is 58.5 grams of salt. Okay, that's what we did in the previous example, and I had erased that mass a minute ago. So now I know my grams of salt cancel. That converts me into the mole. Now, don't worry about doing your math yet. Let's just continue the equation. I know 1 mole of NaCl. Notice the one that I'm trying to get rid of always goes on the bottom. I was trying to get rid of grams, so grams went on the bottom. That converted me to moles. I wanted to get rid of moles, so moles had to go on the bottom. I know 1 mole is 6.02 times 10 to the 23rd atoms. Now, in this case, we know it's atoms, but I mentioned earlier in the video, particles could also mean molecules or formula units. If we're talking about salt, we're talking about formula units. Okay, so there is 6.02 times 10 to the 23rd NaCl units in here. My moles of salt cancel. We can ignore the ones, they're not going to change anything with our math. Now, when we think about it, and if you're looking at an answer before you even get the answer, I know a mole is 6.02 times 10 to the 23rd, and I know a mole is also 58.5 grams, but I only have 5 grams, so my number should be a lot less. Okay, at least 10 times less, because if we compare 5 to 58, I know I have about 1/10 of my material. So if we take 5 now, and I'm going to multiply 5, I'm going to multiply that by 6.02, and then I'm going to divide it by 58.5. And what we get is 0.5 times 10 to the 23rd. Now, 0.5 would not be correct because it's not a number between 1 and 9.9. So I got to move my number over one place. We call it 5.0. Because I'm normally going to the right with 10 to the 23rd, and I've already moved it one place, now it's 10 to the 22nd. So when we look at this, again, does it make sense for what we gave you before? I know I have less than a mole, and obviously we know a mole is 10 to the 23rd. 10 to the 22nd obviously is a factor of 10. We talked about that a few minutes ago. Moving my decimal one place over, about 10 times less. Going from 6 to 5 looks similar, just like 58 is to 5. We're just moving, if I move this decimal over one place, it looks like 5 something. So again, it should look and should make sense. So we can go from one to another. Now, all of these that we've been doing so far are in the same material. The question is, what if I want to go to a totally different material? So let's get rid of this. And in class the other day, we do a lab and we calculate percent composition of a material, and we do a thermal decomposition. We end up deriving off oxygen, and they have to calculate certain things. And so we started out with potassium chlorate. We heat it up and we get potassium chloride and oxygen. So we drive off the oxygen. And they have to do some calculations along the way, and they started with 2 grams of KClO3. But the question is, how much oxygen should we get? Now, we can do what's called a theoretical yield. We can go through a series of these steps, but instead of going from mass to moles to particles like we just did, we're actually going to go mass to moles, and then we're going to convert to a different material in the mole and come back to mass. So you can actually convert as long as you have a balanced equation. So the example here, we started out with 2 grams of potassium chlorate, and I'm just going to use rough numbers from memory. And I know that 1 mole of KClO3, and again, we would need to calculate it out. I believe the correct number was 122.6 grams for its molar mass. So going from mass into moles, again, we are dividing by gram formula mass because we're going this way, so we're going to divide by that gram formula mass. So that's going to get rid of the grams of potassium chlorate and put it into moles of potassium chlorate. But now I want to convert to the other material because I want to solve for oxygen. So I can use my known formula, and I'm going to use the proportions and the ratio that's available. I know that for every 2 potassium chlorates, I get 3 moles or 3 molecules of oxygen, depending on how you want to phrase it. So I can set up a conversion factor. The one I want to get rid of has to go on the bottom. So I know that moles of KClO3 go on the bottom, moles of O2 go on the top, but I have to use the proportions that are set in the balanced equation. So I know there's 3 moles of O2 for every 2 moles of KClO3. So my moles of KClO3 cancel. Now I can convert again, but now I know moles, and now I'm going to come back and I'm going to figure out my mass of oxygen. I know that 1 mole of O2 is 32 grams of O2. So moles cancel. So now I have a variety of things in here. Okay, I got lots of numbers. So we're going to calculate 2 times 3 times 32, or 6 times 32. And then we're going to divide it by 122.6, and then we're going to divide it by 2. So divided by 122.6, and then divided by 2, and we get 0.78 grams of O2. So that is a theoretical yield. Now that was a very large, more complex conversion. Again, that was mass to moles to moles to mass, going from one material to another material. A lot of things you would need in that. Obviously, you would need to know how to calculate the gram formula mass if it was not provided. Okay, we gave that to you here. You need to remember the molar mass of oxygen is a diatomic. Remember, you have to double that up. And obviously, how to calculate and set up your conversions correctly. Remember, the one you're trying to get rid of in the next step goes on the bottom. The one you're trying to convert to in the next step needs to go on the top. So we've done a lot here in this video. I highly recommend you watch it over again. If you did not understand something, make sure you watch and review that part, because we went through a lot. We went from mass to moles, moles to mass, moles to volume, volume to mole, mole to particle, particles to volume. Then we did mass into particles through moles. Okay, we've done 7 or 8, 9 different things here that have kind of encompassed, what you might do on 5 or 6 different worksheets or activities. Okay, now this last one that I saved for the end, I have not really seen the New York State Regents exam ask something that in depth and that many steps. Not to say they couldn't do it. They would often maybe just do maybe a 1 step or possibly 2 steps. It's been a long time since I've seen a 4-step one, but it's important to know that that's how you calculate things like theoretical yield. From there, you could then go and do your actual lab work, and you could calculate maybe percent error and figure out how well you did in that experiment. Did you need to do it over? Maybe figure out maybe where some of the mistakes you made were. So hopefully you've enjoyed this video. Be sure to subscribe so you follow along and you can get access to other videos that I share, and you can follow along with me in your growth in chemistry. So like I said, if you have any questions or comments, just leave them below, and I look forward to hearing about your success on the next exam. Thanks.